So you're welcome back. Now we're going to look at the logarithmic differentiation. Under this topic, we're going to look at some of worked examples and we look at the principle behind logarithmic differentiation. Now, recall, whenever you differentiate ln x, you have 1 over x. Do you remember that? Good. So this principle follows the fact that if you differentiate ln x, you have 1 over x, and if this x is now replaced by a function f, then you have differential of ln f giving us 1 over f multiplied by differentiation of that function itself. That is all. So let's say, for example, you're given y equals uv over w. Now, another thing you need to know is that we apply logarithmic differentiation whenever we have more than two functions, either in the product form or in the quotient form. If you remember in our previous videos, we've been talking about two functions, multiplying each other or dividing each other. Now we're going to be talking about three functions. Instead of following the long method, where you differentiate the 1 and 2, make the third constant, and so on, we don't need to go through all those stress. We can simply apply what we call logarithmic differentiation. For example, let's assume we are given y equals uv over w. What we need to do is to apply logarithm to both sides. So this becomes ln y equals ln u plus ln v over becomes negative ln w. Okay? So we then differentiate both sides now. If you differentiate ln y, what do you have? You have, using this principle, you have 1 over y, right? dy dx, okay, equals to 1 over u du dx plus 1 over v dv dx minus 1 over w dw dx. Since we are looking for dy dx, we then make this the subject of the formula. And how can we remove this? Is by multiplying all through by y. So by the time you multiply this by y, this will what? Cancel out. So we are left with the y dx equals, if I multiply all this by y, and what's our y originally? UVW into bracket 1 over u du dx plus 1 over v dv dx minus 1 over w dw dx. As simple as that. In summary, we apply logarithmic differentiation when we have more than two functions, either in the product form or in the quotient form. Now we're going to look at